Welcome to the lecture series on database management systems. In this lecture, we talk about relational algebra. Once data is stored in the form of tables, which are treated as relations as per mathematical modeling, given a query, our requirement is to produce an answer to the query. So, once a query is posed, first we need to identify the tables in which the relevant data is present, and the next step is to chalk out a plan how to derive the answer or the required data from the tables. To derive the answer or the required data from the tables, we need to have operations on the tables. Relational algebra provides such kind of operations which are dependent on the concept of relations in mathematics. By performing those operations in a specific combination, we should be able to produce the answer. So in relational algebra, it provides operations that can be performed on the tables or called relations to produce the answers. In relational algebra, since tables are treated as relations, on relations in mathematics and relations, we have several operations like union, intersection, set difference, cross product, and division. These are the operations that we can perform on relations. Apart from that, to select specific rows, we have a select operation. To select specific columns, we have projection operation. And a special case of cross product is called joins. Several types of joins are also described. Apart from that, set functions can also be done like sum, average, count, any, max, or min. So by combination of these operations in a specific order or required order, we can produce the answer whenever data is present in the given set of tables for a given query. Select is a basic operation on tables. The nomenclature says select condition on tables. So when this operation is performed on a table, it specifies the rows which satisfies that condition. The condition may be on any set of attributes or values of the cells. Once those rows satisfying the condition are identified, it retrieves those rows only. In this example, students is the table, and we are specifying condition on name of the candidate or student and suburb, a specific suburb. So once those rows which satisfy the condition of name is equal to Mary and suburb is Bodwara, it gives you the answer. So 3 rows are present, and those 3 rows will be given as an output. Project is the next operation. Similar to that of select, which identifies the rows, project identifies the columns from the table. There may be any number of columns, but whatever columns that you specify in the projection operation, it retrieves only those columns from the table. So in this case again, from the students, if we want to project only one column suburb, we can specify pi is a notation that we use, which is for projection. Pi suburb on students, it gives you only one column. Like this, we can specify any number of columns. Project is the next operation. Similar to that of select, which identifies the rows, project identifies the columns from the table. There may be any number of columns, but whatever columns that you specify in the projection operation, it retrieves only those columns from the table. So in this case again, from the students, if we want to project only one column suburb, we can specify pi is a notation that we use, which is for projection. Pi suburb on students, it gives you only one column. Like this, we can specify any number of columns. Now we will see how to combine these operations of select and project and what are the advantages of this. Given a table consisting of students, consisting of name, student name, roll number, address, marks, and attendance, the first query says sigma marks greater than 90 on students, and then pi s name, roll number, and address. What does it mean? First, we select only those rows from the students table where marks column has more than 90 value of marks is greater than 90. Once those rows are selected, from those rows only columns of sum, roll number, and address will be given as an output. So if we describe it in English, it is equivalent to saying that gives the data containing S name, roll number, and address of those students who got more than 90 marks. The same thing can also be done in a different way. First, we project S name, roll number, and address of the entire set of students table, and then we select only those rows from that projection where marks is greater than 90. So this can also be done. Of course, in this query we have one more addition. From that, we can have another selection consisting of address whose value CS is equal to 103. So like this, we can compose the operations or combine the operations in any order so that the required answer can be obtained. But the composition depends on the requirement. If you change the composition, the answer may vary. So the composition is very crucial here.